Hello and welcome. So today we are going to build RC low pass filter and RC high pass filter. So before we dive into that, we need to know some basic information about frequency, time sampling, and the board on which we are going to make our circuit called as breadboard and our ADALM kit. So let's start with frequency. So number of cycles per second is frequency. So in the first diagram, between 0 and 1, this sine wave is completing its 2 cycle. That means its frequency is equal to 2 Hz. So what will be pictorial representation if I increase frequency of anything, any wave? If I increase its frequency, now you can see that there are 3 sine waves between 0 and 1. And on decreasing the frequency, the sine wave is reduced to 1 between 0 and 1 second. So for the first, the frequency is 2 Hz. For the second, frequency is 3 Hz. And for the last, frequency is 1 Hz. So now we talk about time sampling. So in the first diagram, you can see that this sine wave is completing 2 cycles in 1 second. And now I have increased my frequency. That means that there are 6 cycles in the 0 to 1 second. But if you have to represent this from 0 to 10 seconds, there will be 60 sine waves. To avoid that messy condition, what I have done is I have just changed the time sampling. Just changing the time sampling means creating the more area for the curve. It does not affect the frequency. It only gives us good pictorial representation. So now in between 0 to 0.5, there are only 3 sine waves. Frequency is still 6 Hz. But now the time sampling has changed to give a good pictorial representation. So this is the board that we use to make our circuit. So you can see that there are many holes present here. So you can divide this board in 4 parts. So this is part 1, part 2, part 3, part 4. But the 2 parts are similar. So part 1 and part 4 are similar, and part 2 and part 3 are similar. So if you keep the breadboard like this, and if you apply voltage in the part 2 of this board, if we are applying 5 volt to this 45, so all the pin in line with it will get the same voltage. That means that these pins are internally connected. So for the part 1, these pins are, so all the pins starting from here, from 1 to 60 are internally connected. So part 2 pins are connected internally in this manner, and the part 1 pins are connected like this. So this is the circuit for low pass filter. So red wire is going in one side of a resistor, orange is for the output, and the violet wire is the ground. So for the experiment of both low pass and high pass filter, we are using a resistor of 100k ohms, means 100,000 ohms, and a capacitor of 0.01 microfarad. The R and C are in such a way that cutoff frequency is equal to 159.23 Hz, which we can say that it is equal to 160 Hz. So I have connected this red wire in the channel A of ADALM kit, and violet in ground, and orange wire in channel B. So orange wire is connected in channel B to get our output. So after all the connection, we have to give input through this pixel pulse to software. So on the interface, you can see that this is channel A and this is channel B. So we are giving input through the channel A and getting the output through the channel B. So for that, I click at this icon and change the voltage to sine and set the lower value to 0.5 and higher value to 3.5. That means that the lowest point of our sine curve is 0.5 volts and highest point of our sine curve is 3.5 volts. And change this frequency to some 10 Hz. And go and click to play. So this is the output that we are getting. So at the 10 Hz, this output is equal to 2.7 volts. And by clicking here, we can change our sample time to 10 milliseconds. So we have to increase the sample time to 1 second. So this is the curve that we are getting. Now we increase our frequency to 20 Hz. After typing 20, we have to simply press enter. It is 2.68 volts at 40 Hz. This is 2.64. At 60 Hz, 2.57. 80 Hz, 2.4958. And 100 Hz, it is 2.50, 2.4. At 120, this is equal to 2.33. 140, 2.316. 160, this comes to 2.18. So now we have touched the cutoff frequency, and after that this voltage, which is peak to peak, will start decreasing. So at 200, it is 2.13. At 250, 2.14. So we go and change the sample time to something at 100 milliseconds. So at 1.4, it is going at 2.50 Hz. At 350 Hz, this is 1.0, 1.1. At 400 Hz, 0.9. And at 450 Hz, this is 1.08. At 600 Hz is 0.72. At 800, it is 0.65, 0.8. At 1000 Hz, so we again go and change our sample time to 10 milliseconds. So at the 20 Hz, now I have applied the frequency equal to 20 Hz through the channel A, and at output we are getting 0.4 equal to 0 volts. So this is the property of low pass filter. So it passes the frequency lower than its cutoff and reduces the voltage above its cutoff frequency. So this is the circuit for our high pass filter. So we are giving input to capacitor and connected resistor to the ground, and we are measuring the output through channel B through this orange wire, and orange wire is going in channel B, and red wire is going in channel A, and violet wire is going in ground. So now we are giving input to our high pass filter. So now channel A is connected to capacitor, and ground is going to the resistor, and channel B is measuring our output. So I have changed this lower voltage of this high pass filter to 2.5 and higher to 4.5, and the frequency is currently 500 Hz, which is above the cutoff frequency. So you have to go and change this to some 10 Hz. So for 10 Hz, it is 0.1, 0.9 volt, and for 50 Hz, it is 0.33. For 80, it is increasing. For 120, this goes to 0.6, 1.3 something, and at 140, 0.7. 150, it is 0.8, and at 200 Hz, this is equal to 0.9. If I apply the frequency equal to 500 Hz, this is equal to 1.2. At 1000 Hz, 1.49. At 1500 Hz, this is 1.64. And at 2000 Hz, now it is equal to 1.62, and we change the sample time to some 10 seconds. Sample time to 10 milliseconds. At 5000 Hz, this is 1.7. At 10,000 Hz, this is 1.7 volts. So in the high pass filter, we have seen that at the lower frequency, the V peak to peak was low, and at a higher frequency, V peak to peak was high. So this is the property of high pass filter. So now we have collected enough data, and now we go to Excel and plot the graph.